friends, let's move on to the assignment 2. It is a theorem. If P star is a refinement of P, then LP of alpha less than equal to LP star of alpha less than equal to UP star of alpha less than equal to UP of alpha. I have to prove this. Here, P star is a refinement of P, which means if P is our partition, then P star is the bigger partition. Right? It contains extra elements than P, more elements than P. Alright, let P be our partition of closed interval AB having the elements x0, x1, x2 up to xn, and let's define capital Mi to be the supremum of fx. Oops, I'm very sorry. Thank you. Let's define Mi to be equal to the supremum of fx over the closed interval xi minus 1 xi, and small mi is infimum of fx over xi minus 1 xi. Suppose first that P star contains just 1 point more than P. So let this extra point be x star, and let this x star lies between xi minus 1 and xi, where xi minus 1 and xi are the two consecutive points of partition P, right? And in between these 2 points, I'm having the point x star, right? So if you look at this figure, this is your closed interval AB, right? And suppose I'm having the points here as this is your x0, this is x1, this is x2, so on. Let this point be xi minus 1, and this is xi, so on, and this is equal to xn, the last one. And this middle point, which I have supposed to be x star lies between xi minus 1 and xi, right? Now look at here, up to x0 from xi minus 1. Up to this, my small mi and capital Mi, that are same for both the partitions, right? So up to xi minus 1 mi and small mi, these are same for both the partitions P and P star, right? Similarly, from xi up to xn, again I'm having same mi and small mi. For both the partitions P and P star, right? The difference comes in between here, right? Alright, so I have to define W1 to be equal to infimum of fx over this xi minus 1 up to x star for this segment. Okay, so this is xi minus 1 and x star. And let me define this W2 to be the infimum of fx over this x star to xi, right? Over this. X star to xi. Easy? Alright. Now clearly, I know that the infimum of fx over this closed interval, this is greater than equal to the infimum of whole closed interval AB, right? So, infimum of fx over this closed interval, the smaller one, that is W1, is always greater than equal to infimum of fx over greater closed interval, that is AB, this one, right? And again, infimum of fx over this closed interval, that is W2, is always greater than equal to infimum of fx over this large closed interval AB, which is mi. Okay, fine. Okay. Hence, I have to just get to know about the difference of LP star F alpha minus LP F alpha. Let's calculate this. See, up to x0 to xi minus 1, all those summations will cancel out. Okay, because P and P star are same, right? So sum will be cancelled out. The value for the L, P star F alpha from x0 to xi minus 1 will be cancelled out. And from xi to xn, again, this sum will be, this difference LP star F alpha minus LP F alpha, this will be cancelled out, right? So I have to calculate it only this difference for this closed interval, okay? So this will be equal to, now how to calculate LP star F alpha? Yes, I have to multiply, yes, W1 with, yes, the value of alpha at x star minus the value of alpha at xi minus 1. This is the formula. The value of alpha at x star minus alpha at xi minus 1. Very fine. Okay. Plus, now for this from x star to xi. So this is W2, the value of alpha at xi minus the value of alpha at x star. Okay. Minus, okay. Now LPF alpha, I have to calculate the LPF alpha. Now for this xi minus 1 up to xi, what is my infimum? For P partition, it is, for LPF alpha, it is only mi, right? Multiply with alpha at xi minus alpha at xi minus 1. Sorry, it's not visible. Let me write again. Okay, this mi is multiplied with alpha at xi minus alpha at xi minus 1. I hope it's very clear to you. All right. So next, this is equal to, now, I know that instead of writing W1, I'm using this. This W1 is greater than equal to mi. So can I write, instead of equality equal sign, I can write greater than equal to mi in place of W1. And I can also use W2 greater than equal to mi. So I can also replace this W2 with small mi having this greater than equal to sign. So let's replace them. So this is greater than equal to, because W1 is greater than equal to mi. So I'm writing mi over here instead of W1. So it is alpha x star minus alpha at xi minus 1 plus, again there it is mi, alpha xi minus alpha x star. Then remaining it is mi alpha xi minus alpha xi minus 1. Now when you open this, whole thing will be cancelled out. So this is mi alpha x star minus alpha xi minus 1 plus, this is alpha xi minus alpha x star minus, this is alpha x. I have taken mi outside. So this is alpha xi plus alpha xi minus 1. So from all of these three terms, I have taken mi outside. So now everything will be cancelled out. This will cancel out with this. This will cancel out with this. And this will cancel out with this. Remaining it is 0. Which means this LP star f alpha minus LP f alpha is greater than equal to 0. Which means LP star f alpha is greater than equal to LP f alpha. So up to this we have proved. Okay. Now if P star contains k more points than P, then repeating the above arguments for k times, we can reach again at this 1. So let me write this as we have reached, this is LP star f alpha minus LP f alpha. Okay. LP star f alpha is greater than equal to LP f alpha. Let's mark this as 1. So this is about if I'm having one extra point in P star. And we suppose I'm having k more points in P star than P. Then by repeating the above argument for k times, we can reach again at this 1. Right? Hence, LP f alpha is less than equal to LP star f alpha. Mark this as 2. Similarly, we can prove that UP star f alpha is less than equal to UPF alpha. Right? Mark this as 3. So from 2 and 3, we get our required result, which is LPF alpha is less than equal to LP star F alpha and we know that LP star F alpha is always less than equal to UP star F alpha, and this is further less than equal to UPF alpha. Hence the proof. Alright. Thank you so much. Let's carry on to the next video the next time. Thank you.